All right, welcome to the Explainer. Today, we're cracking open the body's own repair manual. We're going to see exactly how it manages to fix one of the most intense injuries we can go through, a broken bone.
So let's just jump right in with a question that, a lot of us have probably thought about, especially if you've ever been unlucky enough to break something. What is actually going on when a bone breaks? Trust me, it's way more incredible than you'd guess.
Yeah, see, a fracture isn't just some little crack. It's a really violent event. It literally shatters the structure of the bone. But, and this is the amazing part, that same violence kicks off this incredible chain reaction inside your body, a whole process designed to rebuild from the ground up. Okay, so first things first, let's really get into what a fracture is and all the different ways a bone can break. Because you know what? Not all breaks are the same, not by a long shot.
So the biggest difference right off the bat is pretty simple. Did the bone break through the skin or not? If it stays inside, that's a closed or simple fracture. But if it pokes through, well, that's an open or compound fracture. And that's a whole different ballgame because the risk of infection goes way, way up.
Now, take a look at this. This is what's called a comminuted fracture. And yeah, it's as serious as it looks. This is when the bone doesn't just break, it shatters into a bunch of different pieces. You usually see this kind of thing from some really intense trauma, like a bad car accident. And it doesn't stop there. There are other kinds of breaks too. You've got greenstick fractures. That's a partial break you see a lot in kids because their bones are still pretty flexible. Then there are stress fractures, which are basically overuse injuries. Think about athletes who are constantly putting strain on their bodies. And sometimes a bone breaks because a disease like osteoporosis has made it weak. That's a pathologic fracture. Finally, you have compression fractures, which often happen in the spine, especially in older folks. So the second a bone breaks, your body just springs into action. There's no hesitation. It's like an alarm goes off, and this highly skilled emergency construction crew is instantly sent to the scene to get to work. And here's the game plan, the step-by-step blueprint your body follows. It all kicks off within hours. First, a hematoma forms. That's basically a big blood clot that seals off the area. Then, over the next few weeks, the body starts building a sort of soft scaffold called a soft callus. That gets replaced by a hard callus, which is like a temporary bridge made of new bone. And then for up to a year, yeah, a whole year, the bone keeps remodeling itself, getting stronger and refining its shape until check this out. You can really see the whole thing unfold here. It starts with that initial injury in the blood clot. Then you can see that callus forming, that natural scaffolding I was talking about. And finally, you get to the finished product, a fully healed, remodeled bone. I mean, it's just a biological marvel, isn't it? Now, as amazing as the body is, sometimes it needs a helping hand. The biggest job for doctors is making sure those broken pieces line up perfectly so the bone heals in the right position. If it doesn't, you're not getting your full function back. So the very first step is called reduction. It's just a fancy word for getting the bones lined up again. Sometimes a doctor can do this from the outside just by manipulating the limb. That's a closed reduction. But for the really messy breaks, they have to do an open reduction, which means surgery. They've got to go in there and put the pieces back together by hand. Okay, so once the bones are lined up, you have to keep them there. They can't move around while they're healing. And there are two main ways to do that. Internal fixation, which means putting hardware inside your body, or external fixation, where a frame is built on the outside. And here you can really see the difference. On one side, you've got plates and screws right on the bone itself. That's internal. On the other, that's an external fixator. You can see how pins go through the skin and into the bone, and they're all connected to this big frame outside the body. It looks intense, but it's brilliant for holding everything stable, especially when there's a lot of damage to the skin and muscle around the break. All right, so the bone is set, it's stabilized. What's next? Well, now comes the waiting game. The next phase is all about keeping that bone perfectly still. This part is absolutely crucial. If it moves, that callus can't form properly, and the whole healing process gets messed up.
For most of us, this part means getting a cast. And wow, have casts changed over the years? You can see here the old school plaster casts. They're heavy, they take forever. We're talking days to dry completely. Compare that to modern fiberglass. It's super light, way stronger, and it's hard as a rock within minutes. It's a total game changer.
So yeah, materials like fiberglass just make the whole recovery process so much better. I mean, they're tougher, they're lighter, and some are even water resistant. Think about what that means for the person stuck in one for weeks on end. It makes life way more manageable. But it's not always about casts. Doctors have other tools too. You've got splints, which are usually for right after the injury happens. They help keep things still and control that initial swelling.
Then there are braces. They're for longer-term support, but they're cool because they often let you have a little bit of movement. And of course, getting the cast or brace off isn't the end of it. That's usually when the real work begins, with physical therapy to get all your strength and motion back. Now, healing is this amazing, complicated dance of biology. But because it's so complex, well, things can go wrong. And when they do, the road to recovery can get a whole lot tougher. So here are some of the big roadblocks doctors are always on the lookout for. We're talking serious stuff, like an infection that gets right into the bone. That's osteomyelitis. Or dangerous blood clots. And sometimes the swelling can get so bad it actually becomes a threat to the entire limb.
Let's zoom in on one of these for a second. Fat embolism syndrome, or FES. This one is pretty rare, but it is absolutely life-threatening. What happens is, after a big fracture, especially in a long bone like your thigh bone, fat from inside the bone marrow can actually leak out and get into your bloodstream.
And once those little bits of fat are in your bloodstream, they can travel anywhere. Most often they end up in the lungs, and that causes a whole cascade of problems. Suddenly you can't breathe, you might get confused, and there's often this very specific rash. It is a full-blown medical emergency.
Okay, and here's another really scary one, compartment syndrome. Think of your muscles as being wrapped in these tight containers. Now, imagine there's so much swelling after an injury that the pressure inside that container just skyrockets. It gets so tight that it starts to squeeze off the blood supply. If doctors don't get in there with surgery to relieve that pressure, like right away, it can cause permanent damage to the muscles and nerves. So, look, despite all these scary risks and just how violent a break can be, the big takeaway here is how unbelievably resilient our bodies are. The whole process, from start to finish, is just this powerful example of the body's built-in ability to fix what's broken. It's pretty incredible. And it really makes you think, doesn't it? If our bodies have this mind-blowing ability to take a shattered bone and completely rebuild it good as new, what else are they capable of? What other amazing self-repair systems do we have that we haven't even begun to understand yet?